Today we will be learning about projectile motions. I will go over 3 different question types that will cover 97% of the questions that come in your exams. On the right is the easiest one. The projectile starts and ends at the same height. On the middle one, the projectile is thrown straight. And on the left, we have the tougher ones that starts from a different height and ends at a different height. These 3 different types are the fundamental of projectile motion questions. So let's understand what is projectile motion. If you throw a ball to someone standing in front of you, the ball will rise up and then move forward, and after a few minutes will fall back and the person will catch it. This curved pathway is called the projectile motion. At the beginning of the ball's journey, the ball moves high up. As the ball is moving against gravity, the vertical velocity decreases. After reaching its maximum height, the ball starts falling back to the ground and its vertical velocity starts to increase. This change is represented by the red arrows in the diagram. However, the horizontal velocity does not change as the gravity is not pulling the ball towards the right. So the ball moves at a certain velocity along the horizontal line. As there are 2 different types of motion, we need to divide this into 2 different components. Let's name them horizontal components and vertical components. Now let's learn to divide velocity into different components, vertical and horizontal. As this ball is moving at 17 degrees to the ground, the vertical component would be 15 sine 17 and the horizontal component will be 15 cos 17. So if we change the angles on the right hand diagram, we can see the vertical component becomes 15 cos 73 and the horizontal component becomes 15 sine 73. The side closer to the angle always has cos. That's a neat trick. By the way, in the calculator, 15 sine 17 and 15 cos 73 has the same value. So you can pick whatever angle you want. Also remember, horizontal doesn't always mean we have to use cos. Horizontal component can be cos or sine. That is dependent on the angle position. Now let's jump into the first type of question. Here you can see a ball has been thrown away from the cliff at 17 meters per second. At the beginning, we can see the vertical velocity is pointing upwards, and after a while, we can see the vertical velocity is pointing downwards. As velocity is a vector quantity, we can choose any one of these to become the negative by using negative v while calculating. As gravity pulls downwards, vertical velocity moving down will increase. That is why I prefer using positive values pointing downwards. And the vertical velocity that is moving upwards is given a negative value. You can choose the opposite, but I prefer using the positive velocity value for the downward movement of the projectile motion. Throughout the projectile motion, horizontal velocity remains constant as gravity does not pull on the horizontal scale. The question also says that the ball has been thrown at an angle of 30 degrees and the cliff has a height of 30 meters above sea level. Let's break that 17 meters per second into components. Initially, the vertical component would be 17 sine 30 and the horizontal component 17 cos 30. As you can see, the angle is between the horizontal line and the main line. That's why the horizontal component is given the cos and the vertical component is given the sine. Here you can see the 4 Suvat formulas that we will be using throughout the maths. Here again, when an object moves downwards, acceleration is taken positive as gravity is helping the object increase its speed. So when calculating the downward movement, I always take acceleration due to gravity as positive. Moving on, let's say the question asks for the maximum height of the ball. I do not have the time, so I cannot use the formula v equals to u plus 80. That is why I will be using the formula v square equals to u square plus 2as. As we need to find the height, which is a vertical component, we will be using the vertical values for velocity. That is why in the initial velocity I am using 8.5 meter per second, and the final velocity, when the ball reaches the top, the vertical velocity is 0. Then the answer comes out to be 3.68 meter. The next question says, at what vertical speed is the ball landing on the water? As we already know, at the top the vertical velocity is 0. We will be using that to find the correct equation. Now the total height of the ball above sea level is 33.68 meters. The initial vertical velocity is 0, and as the ball is falling towards the ground, we will be using a positive value for acceleration. Here the answer comes out to be 25.71 meter per second. Here they did not ask for the horizontal or the vertical velocity. They are asking for just the velocity. That means you have to find the actual velocity. Let's say the vertical velocity at the end is 25.71 meter per second. We can use this information and put it in a diagram. In the diagram you can see the white arrow is the unresolved velocity. We need to find this velocity, not the horizontal, not the vertical. So to find this out, we can use our right angle triangle. In the right angle triangle, we can see the angle is 78 degrees. The hypotenuse would be the one we need to find out. And the straight vertical line opposite of the 78 degree, that's the vertical velocity. We can use this formula to find them out. Moving on, if we use sine 78 equals to 25.71 divided by velocity, we find out the actual velocity was 28.28 meter per second. Now remember, this is not the vertical or the horizontal velocity. Let's move on then, shall we? The next question might come is, find the total time of flight of the projectile motion. As we have a lot of vertical velocities, we can use this in the equation v equals to u plus at. Initially, the vertical velocity is upwards at 8.5. Finally, the vertical velocity is pointing downwards at 25.71 meter per second. That is why you can see the two different vertical values have two different signs depending on which side they were pointing at. If you want, you can switch the signs too, but make sure that the signs are different as they are pointing at different directions. The answer comes out 3.49 seconds. Please remember, do not mix vertical components with horizontal components, and always maintain directional sign. Do you need to find the maximum height? Use vertical velocity. Do you need to find the distance traveled? Use horizontal velocity. Always use vertical components for vertical calculation and horizontal components for horizontal calculations. Now let's say the question asks for the range of the projectile, or how far did the ball travel? Also remember, horizontal velocity is not affected by acceleration, so we can use the normal formula, speed equals to distance by time. The time of flight is constant for both vertical and horizontal motion, so you can use time as both. Here you can see, using the normal equation, the answer comes out to be 51.37 meters. For the next part, let's say they are asking for the height of the cliff. As we know the initial and final vertical values, we can use v square equals to u square plus 2as. As you can see, the vertical values are given positive and negative signs respectively. Another thing I want to emphasize here is that when calculating a projectile motion that has the motion moving up and then down, we have to use negative acceleration. This is because moving up, the acceleration due to gravity is negative, and moving down, it is positive. So positive multiplied by negative would give negative. Here you can see the answer turns out to be 30, which we know is correct from our previous maths. In this question, we learned how to find the total time taken, the maximum height taken, the maximum range of the projectile motion, and how important vertical and horizontal components are, as we cannot mix them while doing calculations. We have also learned that time can be used as both vertical and horizontal component. Please subscribe and comment below if you have any additional questions about projectile motion or my video. I'll explain them ASAP. So let's move on to the next question. Question number 2 shows that a ball has been thrown straight out of the cliff. The ball has an initial velocity of 30 meters per second to the right. Here, let's say the cliff is 15 meters high and the ball lands 20 meters away from the cliff. In this example, the initial horizontal velocity is 30 meters per second. The initial vertical velocity is 0 meters per second. As the ball is thrown exactly horizontally right, there is no vertical velocity. If we throw something at an angle, then we can get something horizontal and vertical. The initial horizontal acceleration is always 0. The initial vertical acceleration is 9.81 is due to gravity. Now, if the question asks to find the time of flight, we can use s equals to ut plus half at square. Here, vertical distance and vertical velocity is used. Also, the ball is moving downward, so we are using a positive version of acceleration due to gravity. The answer comes out 1.75 seconds. Next, the question might ask what is the final vertical velocity that it hits the ground. For this, we will be using vertical distance to find vertical velocity. Here we can use v equals to u plus 80. As the ball is moving downwards, we use positive 9.81 and the answer comes out to be 17.16 meters per second. Again, we did not take 20 meters in our calculation as 20 meters was horizontal, not vertical component. Next, if the question asks what is the horizontal velocity of the ball when it hits the ground, we can say that the horizontal velocity is 30 meters per second as horizontal speed is not affected by gravity. So, along the path of the ball, the horizontal speed will remain constant. We can use the concepts that we have learned in the previous question to any questions that come up. So, let's move on to the next question. Question number 3. Here, a ball is thrown above at 53-degree angle at a speed of 37 meters per second. You have to find the maximum distance traveled and the maximum height that the ball has reached. When they have asked the maximum distance traveled, they are asking for the horizontal distance. So we will be using the horizontal component. Breaking it up into components, we can find the horizontal component is 37 cos 53. And the vertical component is 37 sin 53. Their respective values are given here. Here we run into a problem. We do not know any other value for horizontal component except initial horizontal velocity. So we can use two things. One, using the normal speed equals to distance by time formula, or we can use the Suvat formula to find the time and later use that in a horizontal component formula. Let's practice the tougher one, shall we? We will be using vertical components to find the time. The time of flight is the same for both vertical and horizontal component. Here we know that at the highest point, the vertical velocity is always 0. Here we will be learning a new concept. In this question, the ball rises up and falls to the same level. So we can say the level A is the same as level C. So we can say that the height A is the same as the height C from ground level. As their heights are equal, we can say the time taken from A to B will be the same as the time taken from B to C. So if we can find the time taken from A to B, we can multiply it by 2 to find the total flight time. Now we will be using the formula v equals to u plus 80. Here the time is interchangeable. The final vertical velocity at the top is always 0. We have found the initial vertical velocity, and as the ball is moving upward, we can say the acceleration is negative 9.81. Using the formula, we get time equals to 3.01 seconds. That means the total time of flight is actually 6.02 seconds. Now we can use this into the horizontal equation. Here you can see the horizontal acceleration is 0 as gravity does not affect in the horizontal direction. So using the values, we find out that distance is 134.05 meters. As we know, we can also use the easier formula to prove that our answer is correct. Let's use the formula speed equals to distance by time. See, the answer is the same. So in horizontal components, we can use the formula speed equals to distance by time. Suvat equations are used to find the motion under the influence of gravity. Horizontal motion, like horizontal velocity, is not affected by gravity. So we can use the O-levels formula. Speed equals to distance by time. These were the basics. Hope you have understood them all. Feel free to comment on any question that I haven't explained. For more advanced projectile motion worksheet, click here.